morning. Sorry I'm late. Good morning. You just set up the test. The test is available, should be visible in Moodle at the top. And the test will start at 10:30. I thought today I could just do a summary of the normal distribution material. And and answer any questions you have if we have time. So I left you with your own time to review the normal distribution. You had the notes, you had my edited videos, and all the answers except for a few that I'm going to look at together. So let's go here. This is page 19 of the normal distribution notes. All right, so I'm just going to do some summary problems with the normal distribution. We have an hour, and so if you go to this question, how do we answer this question? We want to compare the heights of basketball players, but one's a female and one is a male. So it's only fair to compare them to their peer group, right? So Michael Jordan's height should be compared to the men in general. And Rebecca Lobo, her height should be compared to women's heights in general. And where heights are considered in a large population to have a normal distribution, or let's say at least a symmetric distribution, I can do this, right? I can calculate the mean and standard deviation. But let's say I knew or I assumed, so that's not here, but what we're assuming is that the height is distributed normally with a mean of 69, the mean comes first, and a standard deviation of 2.8. And that's for men. I can put an M here at the risk of confusing you, that's for men. And for women, heights are distributed, this means distributed. Normally with 63.6 and 2.5. So now, how do I compare these? What I'm going to do to see which one is taller relative to their group is convert each value into a measure that's relative to the expected value. Right? So we're going to convert x into z, where z is also normal, but it has a certain set of parameters. It's centered at 0, and the standard deviation is 1. And what this allows us to do is convert 78, the number 78 inches, or the value 78 inches, into standard deviations from the mean. That's what this means. So it's like a new variable. So we take Michael Jordan's height, so that z, number of standard deviations from the mean for Michael Jordan's height, would be 78 minus the mean divided by the standard deviation for men. So I explained in the videos, this is the relationship, I should write it here, between z and x. You take x, you center it, so you minus the mean, and then you divide it by standard deviation to convert it into standard deviations from the mean. Okay, and this is known as standardizing. So now you take 78 minus the mean for men. So there's lots of means floating around, right? We just got to go to the one for men because that's the relevant one. And divide by 2.8. And then we do the same thing for Rebecca Lobo. So the z for Rebecca Lobo is 76, and do the same thing, but now we're going to do this for women, right? So I could put a W here. Again, at the risk of confusing you, I'm going to use the same approach, but a different set of parameters. Let's see about the sound. How's this? Is this better? No. I think my voice is just, well, yeah, it looks like it's controlled. Hold on. I don't know. How's the sound now? Any better? All right, I think I just have to put my mouth closer. I just have to have my microphone closer to my mouth. Okay, so what do you get? So for Michael Jordan, he is 3.21 standard deviations above the mean for men. So what do we call that? 3.21 makes his height, he's an outlier, right? In height. Because beyond 3 standard deviations, we call an outlier for symmetric distributions. And for Rebecca, she's 4.96 standard deviations above the mean for women's heights. So she's an outlier too, but not only that, she's really much taller, right? So she is the taller of the two. That's all we have to do there. We don't have to do anything more than that. Okay? Just to answer the question, it was only about who's taller. A different question could be wanting to know their percentile, the percentile that their height is, like how many, that would mean how many women they're taller than, or how many men they're taller than. But that's not what I asked, right? Just who's taller. So that's the answer. So the conclusion is Michael Jordan's height is 3.21 standard deviation above the mean for men, but Rebecca Lobo's height is 4.96 standard deviations above the mean for women. Rebecca's height is relatively greater among women than Michael Jordan's height is among men. So to do this, I revealed this sort of assumption behind everything, is that these heights are normally distributed in order to be able to do this. Questions? I see Omar wrote the percentiles, but he got one of them wrong. But that's okay though. Let's talk about that for a second. So let's say I wanted the percentiles. To find what that is, you need to go to the standard normal table. But let's talk about it for a moment. The area under the curve of relative frequency histogram is always 100%, right? Now this one, if this is Z, we've converted now to the Z distribution. That means that 0 is in the center, and then every position along here, every value not only tells you the value where you are, but it tells you how you are in distance from the mean. So 3.21 is 3.21 standard deviations from the mean. If I want to know this, I need to go to the standard normal table. And see what that is. Now the standard normal table gives you the left side, right? It's all percentiles, that's all it is. So if I go to the standard normal table and I look for 3.21, I go here, and that's here. So this is correct. It's going to be 0, 1, 2, 3. So this is the first digit, but then these are the second digit, right? So this is 0, this is 1, 2, and 3. So that's the answer. Oh, I'm in the wrong, here. What am I doing? Wait a second, let me see the number again. 3.21, sorry, I'm off. I am thinking about something else. So 3.21 puts us here. 99.93%. Any questions? Hopefully you learned how to use the table. And for the second one now, if you notice, let's go back to the table, 4.96, it's not on the table. The table ends here. Now where is it ending? Let's do the, I'm gonna redraw what's at the top. So this is the drawing for Z, the standard normal. This is the curve. And the curve and the chart are different things, right? The curve goes on further beyond the chart, but the chart cuts off. So let's see, the largest number on the chart is here, 3.49. 3.49 is here. Oh, I'm not there. Maybe here, 3.49, and it says, the chart says that the area to the left of 3.49 is 99.98%. So almost all of the area under this curve. All right. But there's still some things over here, right? There's other values here. At some point, you know, if I'm only going to 2 decimals, I will hit 100%, right? But the chart just stops at 3.49. So we're looking for 4.96 on the standard normal chart. So that could be something like over here. So if it was 4.96, what would be the area to the left of 4.96? What would we say? Given the limitations or delimitations of the chart. Right. So, good. So you see the logic, this will be 100%. Or close. You know, anyway, we're going to say it's 100%. So, the way I've written it here, this is 100%. All right, let's do the next one. So this is another applied case where you have information from a standardized test for two students, and we want to determine who's the better student. Who had the better score? They wrote different tests, but they were both standardized tests, and we agree that standardized tests are normally distributed. So these are the parameters. So for the SAT, that's going to be normal with a mean of 500 and a standard deviation of 100. And for the ACT, a different test, the mean score for students taking it is 18 and the standard deviation is 8. So this is after taking all the results into account, they're able to come up with these measures. So what do? We convert Eleanor's score just like we did for the heights, right? We convert Eleanor's score and Gerald's score. So let's do that. I'm going to write the notation down first. So for Eleanor, it's going to be 680 minus 500 divided by 100. And for Gerald, it's going to be, oh, okay, I wrote it wrong here. Put a mu. Is equal to 27 minus 18. So just remember, you have to go to the right set of parameters. And I could put, Eleanor here. I don't want to confuse you though, right? I mean, at the risk of confusing or not confusing, there you go. That's what we do. And what do we get? Okay, so when I standardize, Eleanor's score is 1.8 standard deviations above the mean for the SAT students, and Gerald is 1.5 standard deviation above the mean for ACT students. So the better student, the better score is Eleanor. That's sufficient for this question, okay? But the next question asks, find the percentile each score represents. So now we're going to go into the tables to look for the percentages, because we've converted this into a Z, a standard normal. Now I want to see I want to look these two up, where Z is normal, 0, 1. So this is what you're doing when you go into the table. You're finding the area under the curve left of these positions. So let's go look for 1.8. On the positive table, 1.8 is here, 9641. You can write it like that, you can write it like this. And of course, this is going to be bigger because her score is higher, right? So she will have done better than more people, a greater percentage. And when you calculate this for Gerald, 1.5, we have to pull down a bit here. 1.5 is here on the table, the chart. 93.32. All right? And we already know Eleanor has a better score, but this is now in terms of how much, well, it's just in terms of the percentage of students that did worse than her. This says the same thing, 1.8 standard deviations above the mean. This, going from here to here, is just using the standard normal table. There's nothing more than that. I'm just going to the table to convert to a percentage, or to the percentile. All right, so then I'm going to ask, so these were what I've done so far. I refer to in my videos as type 2 problems. Type 1 problems are where, so this here I would call type 1 problems, where I just use the table. So Z type 1 problems, right? Where I just go right to the table and read off the Z score for the percentile. Where I have to standardize, I refer to this as up here, I refer to this as X type 1. So you have to standardize first, convert it into a Z type 1, and then solve. So I tend to just say that all you have to do is standardize to get here to the original approach. The other types of problems are problems where okay, so let me clarify one last thing here. What's a type 1 problem is when I give you I'm just gonna say I'm gonna say it in words. Okay, so if I give you the Z-score, you find the percent, or the percentile from the table. Okay? And that's the same here. Here I give you an X score, like I give you a value, and then you have to standardize it to find the percentile. So this is the approach. This is the approach. Okay, so we standardize any other problem that's normal but not standard normal. We standardize first, convert it to standard normal, and then look in the table to find the percentile. So Z to percentile. The other approach, or the other type of questions I ask you, I refer to as backward problems, or X type 2. in this sort of a problem, I give you the percentage or percentile and you have to find, I say score, find the value. In this case, X. So for instance, I want to find out what is the percentile, the 99th percentile. I want to know the X value for which 99% of people are below it for Gerald, okay? So what score should Gerald have to be in the 99th percentile? To do this, given only the standard normal table, I'm going to first find the Z score for doing this. So we're going to find the Z score, which I sometimes call Z because Canadian calls it Z. And so the Z score first, and then we will find X, okay? This is going to be our approach. So first, so this is called a backward problem or a Z type 2 problem. So what I'm going to do is because going from X to Z, all I'm doing is mapping values to how many standard deviations from the mean they are. So they're really in the same position, different from the mean, just there's different values on the bottom of the curve. So what I'm going to do is do this in 2 steps. So backwards problems are done in 2 steps, and I show you to draw this. I demonstrate. You got to draw it first, and you want to draw the position where 99% of the observations are below this value. So that's going to put me beyond the 0, right? To be above 99% should be somewhere over here, should be a distance away. So that's what I'm going to do. I'm going to go a distance away. Draw this. And I'm going to do this first as though I'm working with standard deviations from the mean. So first I want to find Z, where there's 99% below. This is a backward problem, so I have to do the steps in a backward fashion. So I'm going to go to the table and I'm going to first look inside the table for this value and then along the margins to find the Z. So when I go to the table and I look for 0.99, these are all to 4 digits. So I got to see, let's see, all the way to 0.99. There's these two here. This is 0.9901 and this is 0.9898. So this one differs by 0.0002 and this one by 0.0001. So this one is closer. So my rule is to take the closer one. I explain it in the notes. To take the closer one. So I want that one. So that means that I'm at 2.3. 1, 2, 3. 2.33. Does everybody see that? Because this is 0, 1, 2, 3. So 2.30, 2.31, 2.32. This is 2.33. So Z is 2.33 standard deviations above the mean. that's how many standard deviations above the mean that I am. But I want to find x. That's my thing. First I find z, then I convert to x. To convert to x, I do the backward operation, or the I want to have x. So x equals what? X is z or z standard deviations from the mean. This is how I'm going to solve for x. So I put the 2.33 in there. I use the mean that I'm given for Gerald and the standard deviation to solve for the score you should have had. All right? So always draw this so you can position and determine where you are relative to the mean. Because if you end up over here, that's going to be a negative and it could give you the wrong answer if you've done things incorrectly. So be careful to draw, draw this. It's much more cautious. You're showing me what you're thinking and I can see your errors. So let's put these values in. I'm really out of space. Oh, I guess I can do it on the side here. All right. So Z is 2.33. So Z standard deviations from the mean. Z is 2.33. Sigma for Gerald is 6. And then mu is 18. And you get 31.98. So that's the answer to step 1. And this is the score on the ACT. That's the final answer. Any questions? So where does this formula come from? Well, it's the same one we were using before. All I've done is taken this expression for standardization and rearranged it. But it's very easily interpretable, right? Z standard deviation or Z standard deviations from the mean. So as I'm saying it, it's spelling itself out. So you could also just solve this, entering the values that you know. Some students like to do that. So they just put the values they know in here. 2.33 equals x is what you want, minus 6 over 18, and solving for x. Okay, you could also do that. So let's do the next problem. Let's do the next problem. What score would Eleanor have to be in the top 5th percentile. Right, Alex. So the scores up here that I'm using are for the population that took the ACT. The scores for Eleanor are the these are the results for the people who took the SAT. Right. So let's solve. I'm going to erase this. Let's solve for Eleanor now. So what score would Eleanor have to be in the top 5%? To be in the top 5%, she should end up, let's say over here, where there's 5%. So what score should that be? What number of standard deviations above the mean should she be? So she's going to be here, remembering that we're using, for this problem, we're using the, why am I doing this? I'm doing this because I am given a percentage, like here, given a percentage, and I'm asked to find X, I'm asked to find the score. So this is also a type 2 problem. So the steps in doing that are to begin with a drawing, and that drawing represents the standard normal because that's what I have information on. I have very detailed information on the Z or the Z score. And I need to go into the table. If I went and looked this up, that would not be the right approach because the table gives area to the left. So to look in the table, I need the area to the left. It gives percentiles, which is area to the left. So we don't go with the 5%, we go with this other side, with a 95%. And that's what we look up in the table. So that's the area. We look up 95. And you see these two here. Now, neither of them are 95, but they're both equidistant from 95%. This one is 0.0005 below, and this one is 0.0005 above. So because it's equidistant, I will average the two, because I can't decide which one's better, okay? So averaging between those two will give me, I'm not averaging between those two because the average is 95. What I'm doing is averaging between 1.6, 0, 1, 2, 3. So 1.64 and 1.65. Right, because this one corresponds to 1.64 and this one corresponds to 1.65. So in between those two is 1.645. So that's my first step. Step 2 is convert that now from standard deviations from the mean to the score. So x is z standard deviations from the mean for Eleanor's group, right? So z is 1.645. If we remember on top, it was 500 for the mean and 100 for the standard deviation. So this is times 100 plus 500. So when you calculate, I get 664.5 should be your score to be in the top 5 percentile. That's my final answer. Very good. So that's my review. I mean, I can do some more problems. We can just continue doing problems. One student sent me a question. I never got around to doing it. Let me see if I can find it. I don't know. I thought I saw a problem from a student, but I can't find it now. Let me check my. Okay, this is it here. Okay. Okay, it was a problem from the homework. And okay, I'll do Omar's in a minute. I'm gonna look at this one. Oh, I'm just trying to read. Okay, so what it says is the marks on an arithmetic test are normally distributed with the mean. So grades are normally distributed with a mean of 62 and a standard deviation. They don't give you standard deviation, they give you variance. Remember this class, I'm assuming you watched all my videos, okay, and you understood them. So you should know what a variance is. You should know the relationship between variance and standard deviation. And then you can solve this. Right? The standard deviation is the square root of the variance. So this is 15. So once you use that one, then you're fine because you find the right answer. So the teacher wishes to assign A's to the top 14%. So these are the grades. And the teacher wants to give an A to the top 14%. So what she's trying to do, given a percentage, you want to find the score, right? So this is the backward problem. We do 2 steps. Step 1 is we just deal with the z, this is the z curve. And I mark the top 14%, let's say here. So this is 14% under the curve here. But my table only gives me values for the left area, not the right area. So if I want to solve this, I need to work with this side. The left side, if you subtract 100 by 14, is 0.8600 this way. So this is what I look inside for, inside the table, inside the chart. Okay, so look up. So look for this value inside the chart. Okay, you guys are writing me some questions. Okay, let me finish this quickly then. So 8600, I look for this value. 8600. it's not here, but this one is close, right? The closer. So this is 1.08. 1.08. So we'll put 1.08 as the answer. So this one, it's almost at 1 standard deviation. So 1.08 standard deviations from the mean, and then I convert that to a score, a grade. So Z standard deviations from the mean, or Z standard deviations from the mean, is the X I want. So this is 1.08, standard deviation is 15 from the mean, and I get my answer. $78.2. If you don't, I think that's the right answer. Let me confirm. Well, anyway, that's the answer. All right, let's see what else you have for me. Fill volume. Okay, you guys, exactly, the question by Omar about exactly means you're asked to find probability that X equals exactly 614. What did we learn about that? Those are always 0, okay? Because it's a continuous distribution, in a continuous distribution, the area under the curve is only within ranges. You don't have density or area at a certain point. It's just 0 at a point. Okay, Edwin's asking about the test. The test is at 10:30. It opens at 10:30. So I'm gonna let you go in a few minutes so you can get organized and see that test and let me know if you have questions. The test has 15 problems and there's 5 from each of the separate sections, and you can use your resources. Try and answer them. I'd suggest just try and answer them first and then do the ones that give you difficulty, and work with your notes, but don't waste time, right? You have 90 minutes, 15 questions. Six minutes a question. So you can write your answer, your solution, the way you solved it, on separate pages, and then after the test, you can take a breath and scan them and send them to me. I'll give you, 15 minutes to send it to me. What else can I say? Use everything at your disposal except the help of another person. These questions are going to be similar to the type of questions in the homework exercises and the tests, the midterm questions. Okay, Gerardo, I'm gonna have to find that question to be able to solve it because I'm not sure if there's something missing. You know, you guys can send me questions by email or by WhatsApp. Gerardo, where is this question coming from? Okay, I found it. Gerardo, I don't think I have time to do this because you guys have to get settled to write the test. Not sure what to say. I think you guys should go work on the test and don't worry about this problem, okay? I think I need more time to solve it and you guys need to settle and find the test on Moodle and get your papers organized, get yourself settled to write the test, okay? So I'm gonna let you go now and we can talk about this after the test or any questions you have. Email me, do your best, and send me your written work, handwritten work for the test. Any questions? Yes, it will always be 0, Omar. Questions like this one, where it says exactly, or it gives you a question like this with an equal sign, will always be 0. The test will be available at 10:30. Go into Moodle and see. It should be available. You should see it, but you probably can't open it. Okay, so I'll stay back. If you have any questions, I'll stay here till 10:30-ish, 10:35.